Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about mold design projects on title Application of Core Cavity Insert on Tupperware Lid in Plastic Injection Moldings. Okay, we are from 4BMMP S1/1. My lecturer name is Muhammad Faizal bin Halim. Okay, this is my group member. So we have four members in this group. For the first one is Muhammad Shafiq Amir bin Samsuddin, and the second one Muhammad Harizul bin Abdul Razak, and third one Tengku Muhammad Aiman bin Tengku Johari, and me is Muhammad Rizwan bin Azizi. Okay, we go to the introduction of mold design projects. Nowadays, plastic is now used in almost every application, ranging from household articles to space travel, from transportation to packing, from medicine to toys, from bridge building to sports. Generally, injection molding is a process that forms the plastic into a desired shape by melting the plastic material and forcing the plastic material under pressure into the mold cavity. The main concept of plastic molding is placing a polymer in a molten state into the mold cavity so that the polymer can take the required shape with the help of varying temperature and pressure. SolidWorks plastic is the injection molding flow simulation which is added in for the SolidWorks CAD. It simulates the flow of the plastic melt into the mold cavity and provides results. Molding is a manufacturing process that involves shaping a liquid or malleable raw material by using a fixed frame, known as either a mold or matrix.
Thank you, Mr. Rizwan Azizi. Next, for the design of product. The study concerns the design and studies of the Tupperware lid product, which is designed by using SolidWorks 2019 software. The SolidWorks 2019 software model consists of 3D geometry that set its edge, face and surface. The software enables rapid and precise model. SolidWorks software utilizes a 3D modeling approach. After a piece design, 3D model can be created from the initial drawing to the result. Before constructing the design, the actual size of the Tupperware lid must be taken. Next, product outlook design, material uses, correct shrinkage of the material, number of cavities, and selection of the mold base must be set up before designing new mold. Flow diagram of Tupperware lid simulation. First, create a Tupperware lid design in SolidWorks software. Then, select a plastic material for the Tupperware lid, which is a polycarbonate. Then run the gate locator on the design. Next, treat the location injection. Then run the simulation and analysis for the design. Then summary model and flow. Then the generate report simulation by using report generator from the SolidWorks software. For the next slide, which is injection location and mesh Tupperware lid. For the injection location, which is the Tupperware lid in plastic injection molding, is filled with the injection place. The injection site use one injection site for plastic simulation. For both simulation, the injection location diameter is 2 millimeters. For the mesh Tupperware lid, which is In order to analyze flow domains are split into smaller subdomains made up of geometric primitives like hexahedra and tetrahedra in 3D and quadrilateral and triangles in 2D that are collectively known as machines. Next is provide the best balance between analysis accuracy and computation time. This mesh type is approached when there are many itineraries in the part design, and the reason for choosing this mesh type is it does not require too much time to apply on surface with 3 mm size mesh element and 0.3 mesh tolerance for simulation. The solid mesh provides 4,792 elements and 2,398 of nodes. For the insert polymer material, which is in this product the material used, which is polycarbonate polymer. Polycarbonate is a tough, transparent plastic material with outstanding strength, stiffness, and impact resistance. Next, insert fill setting. The injection molding process parameters such as filling time, melting temperature, and the pressure limit shall be defined in the filling setting. The same filling configuration exists for both simulations. Okay, for the next slide, which is analysis result. Polycarbonate is a durable, amorphous, and transparent thermoplastic polymer of high performance, with organic functional group integrated and offering a special combination of properties due to its unique features that include high impact strength, high dimensional stability, and strong electrical properties, among others. PC is widely used as an engineering plastic. Polycarbonate is highly viscous. Its viscosity is typically decreased by processing at high temperature, which is melt temperature for the polycarbonate, which is 300 Celsius, and mold temperature 100 Celsius, and the ejection temperature 175 Celsius. For the more details for analysis result, I will pass to Muhammad Rizwan Azizi for the next slide.
Okay, we go to the result of fill times. As a result, plastic will be tougher and the end product consistency will deteriorate dimension, aesthetic strength, and etc. Any changes in working hours could adversely impact the final products. The blue regions display the start of the flow in that area. The red area shows the flow front locations at any given time interval during an animation of the filling stage. Filling stage and the end of fill when the flow has stopped. The filling patterns radiate from the middles to the opposite corners of the components. Okay, the next of analysis result of pressure at end of fills. During filling stage, the forward injection velocity of the screw is controlled, which results in the pressure needed to fill the cavity at that speed. The injection pressure is generated at the bottom of the reactor and rises along the length of the feed. Pressure at the end of a filling may provide an indication of how much restorative process has occurred.
Okay, for a well line also called a well mark or a midline, is formed when separate melt fronts traveling in opposite direction meet. A melt line occurs if two emerging melt fronts flow parallel to each other and create a bond between them. If well or melt line can be avoided, position them at low stress and low visibility areas by adjusting the gate position and dimension. Improve the strength of well and melt lines by increasing the local temperature and pressure at their location. Okay, for the cooling time, in short, the quicker your cycle time, while importantly retaining a reasonable level of quality, the more quality you achieve with less human machine hours. Proper cooling time is the most time-consuming aspect of an injection molding cycle. The cooling usually makes up about 85% of the total cycle time. The 85% figure is well within the appropriate figure based on the degree of concentration for plastic-based injection. Okay, a seam is usually found on a surface which is adjacent to and opposite to a rib because of unbalanced heat removal or light cause. This happens. Plastic materials are an insulator that do not easily transfer heat, so they slow down the cooling process. The longer plastic cools, the more the material will shrink. The high amount of shrinkage pushes the surface of the component inwards, causing the piece to depress. Okay, for the air traps often result from insufficient vent in piping and tubing, especially in the last to fill areas. It is usually due to the thick-thin fracture process. Entrapped air will result in voids and bubbles inside the mold part. A short mold or incomplete fill or surface defects such as blemish or burn mark. To eliminate air traps, you can modify the filling pattern by reducing the injection speed, enlarging venting, or placing proper venting in the cavity. Okay, next we go to the discussion. In this analysis, the mold component which is simulated by the solid-work plastic under the considered normal condition. Melting temperature of the polycarbonate considered at 300 Celsius. Mold temperature at 100 degrees Celsius. The pressure holding time at 4 seconds. Then the changing of this perimeter with the fixing of perimeter to find the effect of the change of each perimeter on the volumetric shrinkage at the end of the fill and packing. Since the shrinkage is very important output perimeter after the end of the solidification of the molten plastic. So, in this study, it is investigated that the mold temperature effect is inversely proportional to the volumetric shrinkage where the effect of the melting temperature of the plastic material is directly proportional and linearly as well as the melting temperature is rising. The volumetric shrinkage will rise too. Other than that, the the other variable analyzed is the pressure duration. The greater pressure time at the end of the packing and the lower volumetric shrinkage, there are some more parameters relating to the options and the calibration of the injection molding machine, including the time of removal, which is specified as the time measured within seconds, in which the molded part is left inside the mold before opening and ejecting the mold product. Okay, for draft analysis on a Tupperware lid for cork and cavity insert. For draft analysis, a green inner surface show that for the core insert and the red outer surface for the cavity insert. And we examine the faces of the model for sufficient draft to ensure that the part ejects properly from the tooling. All the angles has been
Drafting with a 1 degree. Okay, for the parting line, a parting line is the line of a separation on the plastic part where the two halves of the plastic injection mold meet. The line indicates the part plane that passes through the part. Part line can also occur where any two pieces of a mold meet. This can include side action pins, tool inserts, and shut-offs. Parting lines cannot be avoided. Every part has them. The melt will always flow towards the parting line because it is the easiest place for the displaced air to escape or vent. Parting surface. One surface divides the mold block into two sections, the middle and the cavity. To separate mold cavity from the core, extricate from the parting line, the partition surface can also be used to create an interlocking surface. Tooling split. After tooling split has done, we move the core body move upward, and a cavity side we move downward. Uh, this uh, this drawing show the Tupperware lid core and a cavity. Cavity in a mold base. Insert mold is the thermoplastic material mounting process around a preformed portion insert in order to manufacture a finished part with multiple materials. Usually the inserts are metal parts which strengthen the mechanical characteristic of the plastic component. The center and a cavity design of the plastic injection molding tool give the product shape, but many other functions are crucial to proper product creation. Core and cavity mold insert. Core insert is an extended or male portion of the mold which create the internal plastic part surface, where cavity insert is a depression of female portion of the mold which create the external plastic part surface. This is a isometric view cavity mold. This is the top view cavity mold, and isometric view for the core mold, and a top view for the core mold. For the gate and runner system, gates are a transition zone between a runner system and a cavity. The location of gates is of great importance for the properties and appearance of the finished pipe. The melt should fill the entire cavity quickly and evenly. Type gate used in this project is tap gate. The runner system is in a manifold for distribution of the thermoplastic melt from the machine nozzle to the cavities. The screw bushing and runners should be as short as possible to ensure limited pressure losses in the mold. Okay, this is the smallest way is a gate, and the biggest way is a runner. And the material will go through inside this hole at the middle of the cavity insert. Mold assembly open and close. For open mold assembly, the core insert is supported by core plate, which is a moving plate, moving side, whereas the cavity insert stayed at the cavity plate that's permanently stayed at the fixed plate. Next, you can see the closed mold assembly. Conclusion and recommendation. Conclusion. The production process. A material had to be chosen which could combine real-time mold production properties with a steel suit perfectly. In the development of the mold, the best design was needed to ensure that the molding process was not complicated. The SolidWorks product design has been achieved with all the necessary dimensions. Since the Tupperware lid system complicates the mold design and complicates the manufacturing process of the mold internally, it was important to find out in this paper whether there were defects in the product at this stage, which might be the best system for the closing of the Tupperware lid. The values above were achieved using the SolidWorks mold simulation and analysis program, and no defect in the product design were discovered. Recommendation. The thick walls would create long process time, resulting in a poor mechanical properties. The thinner walls make for easier injecting molding. The component with thin wall are more effective, less costly, and contain less plastic per element. The sharp corners are used to, among other things, focus tension. Bosses with a stud or rib fixed to a surface and strengthened are several other typical positions. The goal is to eliminate sharp corners without adding more material to the wall, which creates a sink problem. Moreover, to completely fill the cavity entirely as quickly and efficiently as possible, the injection pressure must be maximized. If the pressure is too high, injection molded components may be produced that have a high strength.
For lesson learned, we can learn is allow to resolve voltiness issue. Next, able to harness fault in design, geometry, and avoid expensive tooling error. It also gives you more support if need to make a case for design change. Third is improve manufacturability, improve equality and efficiency, and reduce time to market. Fourth, mold flow analysis lets uncover visual defects such as air traps, wear lines, and sink marks, and allow to optimize gate location. The last is another key benefit is using the program to predict generalized molding parameter, allowing for efficient setup during the trial phase. Okay, for the appendix, this is the core insert. As you can see here, this is the cavity insert. This is the Tupperware leads, uh, and this is a bill of material. This is a mold assembly for cavity and core, and also for the product. Okay, that's all from us. Thank you. Assalamualaikum.